Hello everyone. Right, so there are a few buzzwords, 3.0, but mostly just in the title, and I'm going to avoid those. This is a public lecture, so we have to be a bit polite, but also I'm going to try and keep the jargon down. So what you're seeing there, that picture, it's entitled The Geofabric. It's painted by my sister in 2012, and it's her artist's interpretation of a digital map of the river networks of Australia that I was involved with at CSIRO and with the Bureau of Meteorology back then. That project, I'm going to refer to it several times in this talk because while we're all futuristic and so on, some things are done and then forgotten for a while and they resurface themselves. Okay. Right, so the aims of this talk are very simple. I'm going to describe very briefly, and Andy's already done some of that, what GA does with data and why. And there are some people in the audience who are not from GA, so that will be maybe new to some of them. I'll definitely explain what Web 3.0 is, Andy, so you and others will know that term. And then I'm going to talk specifically about the implications or what's going on with respect to spatial data and this Web 3.0 stuff. And then the most important part of this talk is really to update you all on what GA is actually doing here. So we can talk about these definitions, and I could have read them off Wikipedia perhaps, but you want to know what's GA actually doing, what's Australia doing, and so on, and some related international work. So that's where I'm going to spend most of the time. Okay, so what does Geoscience Australia do with data and why? So it is about this is our one of our publicity pieces, Value to the Nation, and we're really trying to leverage or use the information that we've got to best serve Australia. And as Andy has said, we've actually always been a data storage and delivery point. Precursors to GA have of course delivered lots of paper maps, all kinds of physical and written information, and of course now a lot of our information is digital. If you go to the GA website, front page, I mean that's the number of references that you see straight up to data. Data delivery, data things, popular online tools, data. So that's what it's all about. And of course we have lots of, as I said before, physical samples and other kinds of data in big warehouses. That whaling's my small son. Okay, so in our IT strategy, it actually says that our role is to ensure enduring stewardship and maximal reuse of Geoscience Australia's scientific data. So there are people from National Archives here. We take archiving seriously. We've got a couple of different data aspects to that. One is to preserve the data for some time and also to deliver it effectively. Okay, so just some very quick figures. We do have at least 25,000 public data sets, and those are the tangible data sets. Those are the lumps of thing which you can easily identify. There's many more other things that we deliver as well. We deliver 500 plus spatial web services, which is, I would say, easily the largest number of any organisation in Australia. We're an active participant in a number of international and national groups that deal with standards, data management, those sorts of things. So there's a few acronyms which you can Google later on there. And we are the #1 contributor to the data.gov.au catalogue. So here's the splash thing. If you go and look at the contributors, you see that of the 33,000 data sets, we deliver within 70 or so half of that. So that's we've always been around half, and South Australian government's trying to catch us, but we'll see them out shortly. Okay. Now, in addition to those kind of catalogue-y things, there's some very significant and important digital data sets that we deliver. The Data Cube, probably the largest one, but it's not the only one. There are some others too. There's geophysics data sets over at the National Computational Infrastructure, say. So those are not catalogues, those are special fancy things. Okay, so what's all this Web 3.0 stuff about? Now, just generally, of course, we should always be looking at GA to deliver the information that we have in ways that people are able to use, and as those ways change, we should change as well. So we may not have thought of something, but someone suddenly says, "Can you do this?" We should think about doing that. Web 3.0, I'm just about to define it, but it's where we're at for the cutting edge of delivering certain kinds of information, and I'll explain this little picture later on. Okay, so Web 1.0. What's that all about? That's the read-only web, and that's the early days of the internet there. Funnily enough, Tim Berners-Lee, who's associated with inventing certain parts of the internet, he never intended for the web to be a read-only web. The very first web browser which he made allowed you to edit pages and save them and put them up there. So it was actually not read-only even at that point. However, for the first chunk of time, first 10 years or so of the internet, a lot of the web looked like that. And that web page still works, which is an achievement. From 1996, and all of those links work as well, which is, again, another achievement. That's static stuff there, and what the internet's doing for you is putting it up, and you can access it from anywhere in the world, but you can't write anything in there. You're just a consumer at that point. So hello 1996. There are a couple of web pages that are around that go back to about 1994. Still live. Okay, so Web 2.0, the read-write web. This is, I think, known to millions of us all around the world. Now, my Facebook thing there, I don't really use Facebook much. I've posted exactly 2 pictures to Facebook. Those other ones have just appeared. I don't really know how. So yes, I've participated in this read-write web, but I'm not so much into the social side. But I think all of us have at some point contributed something to mailing groups or Facebook or something. So we're all participants in that. Right. So this is where we're up to now, the Web 3.0. So now this versioning is a bit arbitrary. It's whatever journalists who are involved with tech media think sounds good, and I used it to draw you into this talk today. But vaguely, the Web 3.0 is this machine-to-machine internet, which I'll define, and the semantic web, which I'll also define. So I'm going to, rather than just explaining directly, I'm just going to show you a couple of examples that are Web 3.0 things, and that should get some of these points through. This is not a drill. This is actually happening. We're doing this. It's not an idea that we might do. This is really happening, and it's, to some extent we have to deal with it. Which is great. Okay, so for those of you who are fans of 1960s British comedy, you have heard of Terry Thomas. For the rest of you who haven't, you could Google Terry Thomas and this is what you'll see. He's a British actor, and I think we're all familiar with Google, but Google recently have done a couple of things that they didn't used to do. Obviously they're always innovating, and if you look over here, let me just start again. On the left, you see the normal web page links that you're used to. So Google is going along and it's finding web pages with the words Terry Thomas or synonyms of, and it's using a bunch of computers and algorithms to work that out. And it's captured all the web pages and it's doing that. Over on the right here, it's doing something a bit different. It actually knows that it's matched that text, Terry Thomas, to not just a blob of text, but in this case, comedian. And then it said, so it's given it a type. It said this isn't just text, and it's not just text in context, it's specifically a type of thing. And you could do this for George Clooney or whoever your favourite actor is, and it will come up the same. And then it said, okay, not only do I know about Terry Thomas as a thing, a comedian, but comedians are in movies. And movies are a thing, they're a different thing, and it's listed movies that are related to Terry Thomas. Now this is not statistical matching. This isn't just Google saying every time I see a web page with Terry Thomas in it, it's got movies in it and sort of giving you the top 10 hits. It really is knowing that there are things called actors or comedians and things called movies and that they have some real relationship. Of course, the statistical stuff still works on Google. So it says people also searched for, and imagine that Terry Thomas was known for wearing a funny hat. It might say that people who searched for Terry Thomas also searched for funny hats because that was a logical kind of thing to know about him. But in this case, it's listed Peter Sellers and a few other British comedians. So anyway, we're dealing with things on the web that are not just text; they're typed. So that's example 1. That's where the semantic bit of the semantic web comes in. It's semantics being descriptions of things. Okay, so example number 2. So Terry Thomas again, because he's awesome. And this is the Internet Movie Database, a well-known web page that's got lots of information about actors and movies and so on. Now, under the hood, presumably IMDb uses some database system to inform its web pages. You search for something, it'll deliver this information. But until recently, the information that you got on the web was really just described, technically described, in order for it to display nicely. So it would say, put the picture on the left, put the text on the right, make this text big, make this text small. Now Google came along and they read that text and they work things out, but more and more organisations who are delivering their content are adding in information about that content, what it's actually about, not just Google, so that others also can understand that better. So I'm only going to show, I think, 3 bits of code in this presentation, and they're coming up now, so brace yourselves. Okay, so the first bit is, in the code behind that web page you just saw, there is a line in there, amongst the thousands of other lines, most of it being about pictures and stuff, that actually tells you that this page, as in this page, is about a so-called schema.org person. So if we actually go and look up what that thing is, it will tell you. So it's a person who's got legs and arms and so on. And that's what the web page is about. So it's not just about text, it's not just statistically about the words Terry Thomas 100 times and about the words actor 50 times. It's specifically about a person. And that person is defined in this standard or this agreement that various companies like Microsoft and Google have been involved with. We still have that ordinary old web page information in the web page, obviously, otherwise it wouldn't work. So we still have things like heights and widths of images and instructions to tell web browsers how to actually display that information. But even in here you can see in bold it's got additional stuff to say. It's not just things that you put on the place. This is a video object. Inside the video object there are links. The links mean things, they do things. There's real structure there. There's semantic structure, not just a layout structure. So that web page, IMDb, is starting to use some elements of Web 3.0. Not all of them, but some of them. So back to the slide I showed at the beginning of this mini section. What we're seeing is that some of these web pages are now delivering data on the web that is related in particular ways and classed in certain ways. So if this was the web page we just looked at, object A might be a person, and that's Terry Thomas, and object B might be a movie that he was in, and there's a link that says person A was in movie B. That's very different to a web page that just links to another web page. We can actually understand something about the relationships there. And that's Web 3.0 stuff. The other way to look at Web 3.0, and I talked about this last year when I did a series of linked data talks, and if you want more detail on the technicals, you can look up those. They're also in GA's lecture series, not the distinguished ones, not so distinguished. But it's the giant database in the sky. So really, in the same way that if IMDb, that Internet Movie Database, had 2 offices, and those 2 offices produced bits of the web pages and they wanted to make them all work together, they would agree on a way of doing things, and they would use a model and so on, and they would build a database and it would all work fine. This giant database in the sky is what this Web 3.0 stuff is aiming for. So it's the idea that if everybody who used the internet was to agree on certain things, we could think of the total content of the internet as a big database. All right, so the first point here is that a relational database has tables of information that you can join together. So you can have an actors table and a movies table, and then you can say what actors were in what movies, and you can ask those kinds of questions. Actors, movies. Databases like relational databases and other databases require a model or a schema that tell you what joins can be made. There's no point joining a movie to well, maybe there is a pot plant. I'll try and think of something that you can't join it to. But there are certain things that you can ask and certain things that you can't. And that's what a data model or a schema will tell you. And someone like me as a data architect, that's what we're obsessed with all day, is those kinds of things. And a database schema, as opposed to just the picture I showed before, this has got some small information about the relationships between those things. We don't have to worry about the technicals. Okay, so if we had consistency in our data model, we can distribute who can contribute to and use that database. So, if we want to make a database of everything, and I mean everything that we know of digitally, so that could be Terry Thomas, it could be the prices of 3D TVs, which I don't recommend you buy, apparently they're out now. We could talk about things on the GA website, we could talk about things within the data cube, for instance. If we wanted to make a database of all of that stuff, we would use something like Web 3.0. Now there is a data model that parts of Web 3.0 use that's a fundamental data model. It's one of these low-level things like files in a file system that applies to a lot of different scenarios and can be adapted for use in different places. That's the resource description framework. I'm not going to go into any detail about that, but it's kind of a mechanism to allow you to make those connections between different objects in a standardized way. Right, so if we do want to have a schema or a database thing that we can use anywhere, we better make sure that it works at different levels. And that's exactly what that particular model, that RDF model I mentioned, can do. We can describe something in a large amount of detail here, and then we can describe something more broadly and use the same kind of, it's sort of like a fractal model to keep doing explanations at different levels. And that's interesting, and that's a little bit unique about the data models that back this Web 3.0 stuff. So we could describe, for instance, the government departments in Australia at that high level, you know, what they are and what they do using this stuff, and then we could describe the little bits and pieces within a data set using the same tools and techniques. So finally, use the internet itself and the transport mechanisms of the internet to actually perform the joins between things. So if someone publishes information over here on the internet and I publish information over there, and the schema says that we're allowed to join those things together, use the internet to actually facilitate that join. That's the network we should use. And so we need to use the normal internet protocols to do that. Oh, and I'll just mention on this last point that there are, of course, in addition to a data model, query languages and tools and so on to enable you to do those sorts of joins. I might touch on that a little bit later again. Okay, so now the spatial data bit. So there have been a few projects that have realised, well, look, you know, spatial data is very important to us at GA, and it's a if you look at the way information technology is developed, there's been a lot of work in spatial data systems, mapping systems, geo-processing and so on. Spatial is important, and so Web 3.0, you know, needs to be very careful about what it does with spatial data. So I'm showing something here that is a screenshot from a project, that same project I showed at the beginning, the GeoFabric in fact, that is showing you a Google Maps style map of something. It's showing you an ArcGIS style polygon of something and bits and pieces of information. And it's using linked data, which is a standard set of protocols for describing the relations between systems as part of Web 3.0 to give you access to all of those different views of the same thing, and we're going to touch on some of those now. Okay, but there's an important thing to realise here. If we're going to deal with spatial data, a lot of time and effort's gone into dealing with systems that efficiently deal with spatial data. We don't want to be doing something that is less powerful than the techniques we already have. So we might want to use Web 3.0 and these links between datasets at certain points in the datasets, but we don't want to use generic verbose systems to deal with stuff that's already dealt with quite comfortably within a known, especially a known standardized system. So imagine that is an image, and the image has got pixels, and the pixels have locations next to each other, one pixel in the next, and the next row, etc. To describe that, we've got any number of image and geospatial formats and processes that can do that, GeoTIFFs, NetCDF files, all kinds of things. We don't want to do that with linked data and the web. That would be a ridiculous waste of time. And this Web 3.0 stuff has gotten into trouble by trying to do things that it's not appropriate for in the past, and people have thought, you know, you're trying to re-engineer something that we spent forever working out, and it's highly efficient, and you're doing it all again, and you're doing it less well, or whatever the correct phrase is. So what should we do? We should be using the Web 3.0 stuff for metadata about these things, and maybe at some point extents of imagery and so on to allow you to join these things together, but we probably shouldn't take all our existing imagery and turn them into web pages and text and so on. That would be crazy. So we want to link things across systems, and let's see, so this is a related image to that GeoFabric one. What we have here is a catchment, and the catchment is identified with the number 11741. And there are different ways that you might want to see that catchment. You might want to see it on a map as a picture. You might want to see it as a polygon. You might want to see all of the stream segments that are within that catchment. So these are spatial things, and we have different kinds of web services and download data sets that help you see that. And we want to use linked data and the Web 3.0 to firstly work out that they are in fact the same thing, and then to give you access to those different viewpoints where you need them. So this is a landing page for that catchment, which in this case the catchment's northern New South Wales or southern Queensland somewhere, and this web page links to other kinds of web services that deliver this information, some that most of you will be familiar with, web map services, web feature services and so on. Don't worry about the text here, but this is the listing of all of the options that are available to you to view that catchment that we just saw before. And if, for those of you with sharp eyes, you'll see that there are image formats there are text formats, there's all different kinds of formats and different models expressed. And this particular project aims to bring all those together. So if you went to look at this catchment, conceptually it's this catchment, and then which way, how do you want to view that? And a machine can understand this as well as a person. Okay, so one important piece of work that's going on is in relation to Web 3.0 and spatial stuff is it's actually not just the W3C. The W3C is the governing body of the standards of the internet. There's another body too, the Open Geospatial Consortium, which does a lot of spatial standards. It's actually a joint working group between those two bodies to look at how these web standards and Web 3.0 and so on can apply to the geospatial things that we already deal with. So this is just one of their aims. They've got several aims, but to determine how machines and people can discover different facts in different data sets, I think there's a word missing there, that relate to the same place, especially when place is expressed in different ways and at different levels of granularity. So in the last slide I showed you there was conceptually a catchment there and then different ways to think about it. Someone actually had to go and work that out, that in fact this system, what it calls this thing and what this system calls this thing, it's in fact the same thing. And then we can use the internet to get around once we've made that logical connection. Okay, so the important bit, where is GA up to with all of this stuff? So that diagram comes from one of our linked data systems, which I'll mention in a minute. Okay, so in order to be involved in this whole Web 3.0 business, GA has to implement certain things. We actually have to describe what GA is to the machine-readable internet. Our web page at the moment is somewhat machine-readable. If you go to the main GA web page, and Google, of course, being probably the primary example of this, it's a machine, it reads that web page, it just understands information about GA. And if you Google for GA, you'll almost certainly find it. So it's doing a very good job there. But specialized relationships between GA and things in GA, such as particular people in GA, areas of the GA study works on, all kinds of information. Sometimes that's picked up by Google-style machines, sometimes not. And there are certain conventions in describing what things like GA do that we can adhere to. So there's a little linked data or Web 3.0 representation of what GA does there. It's only in test. This is not, it's public, but it's not advertised much. And certain kinds of web crawlers that really know to look for this stuff would be able to understand very specific facts about GA. So I've just put one example down there. GA specifically has a name called Geoscience Australia. Now, of course, Google has worked that out. That's a pretty simple one. But there'll be other relationships which are more problematic. Another way to represent GA, and I apologise, I didn't think about how small this text might be. Just look at the mini heading down there. GA actually publishes an awful lot of stuff, and we can talk about all of the things that we publish and in catalogues, and we can make catalogues of catalogues, in fact. So at least conceptually, GA has got, theoretically, one catalogue that catalogues all of its other catalogues. And there's a mechanism for describing that, such that if one of these web bots comes along and finds this particular web page, it will point it in the directions of all of our other catalogues. And that's what that extra description about GA is doing. So we've implemented some of those things at GA. These kinds of descriptions of data providers, agencies, people and so on, are pretty new. They are one of the ways in which we can ensure that if we publish it, you can get to it from here. We started to put that information out now. Again, this is mostly for the machine-readable side. If you're a human, you probably want to use our main website. That's mostly where you would go. Some other things we've done. Aaron, who's over there, has implemented using identifiers for things in our existing web services, so our geospatial web services, but the identifiers are of a type that are they're web addresses basically, and they work universally and they work across systems. So this is one of the pillars of this Web 3.0, is to have identifiers that identify things unambiguously regardless of where you are and actually give you access to those things. So if you put that web address in, you'll actually get that web services result. It's specifically identifying, in this case, borehole 10,000. And like I showed before, if we had more than one way of describing borehole 10,000, we actually do, but we haven't quite finished the work, you would have a landing page and it would tell you you can view it in this way or that way. So it can work across systems, it can work across institutions as well. So we've started to replace local identifiers with these universal web links. Now don't worry about the specifics here, but what you're seeing is a data model, in this case the so-called GA's public data model. So this is what I work on as my data architect kind of day job, and it's the model, the database schema, which tells us how to relate different things together. Now it's getting bigger all the time because we keep publishing new things, but this bit here is telling us how to relate web services and data sets together, and web services and data sets to vocabulary terms to describe what's in them. So is it about water, is it about Australia, those kinds of things. So there are lots of these kinds of models, and we try to reuse other people's models as much as possible, and the more we do that, the more understanding there is. But we're really, it's that big database in the sky. We're thinking of all the things that GA delivers as one database's worth of stuff. So we're doing some of that. That's just web services and data sets there. Okay, so we're also building a layer on top of our existing systems to get the information in them out in a Web 3.0 kind of way. So most recently we worked on our samples collection. We've got 3 million odd samples in a Oracle database, and it tells you information about the samples, other about rocks, etc., etc. We've applied those universal identifiers to them, as I described before, and we've also taken that information from that Oracle database, we've put it out there on the web in standard web XML, so information that things on the web can read. Then we've added information to it to put it in formats that are semantic. So rather than just seeing that there's a thing called a borehole, it tells you what a borehole is and how it relates to other things, etc., etc. So we've taken our existing systems, added a layer on top. The existing system still works as it did before, so the samples system within GA still works fine, but now we're publishing that information out in a Web 3.0 machine-readable kind of way. One final example on this, we've just started work now on our surveys. So GA holds a lot of information about geophysical surveys that have taken place over time. And those surveys have produced data sets, and we have the data sets in a catalogue, and we have the actual survey information in a database. Now, to merge that stuff together within GA, some of this is unmergeable. The data sets are big blobs of files and so on, and they exist on file systems here, sometimes in other places. It's very difficult to see how you would merge that information together locally. We can do it using the Web 3.0, and that's exactly what we're starting to do now. So shortly, if you're looking at a data set that comes from a survey in our catalogue, you'll be able to find a link across to information about that survey that we're now delivering out from our Oracle database. And a machine can do the same thing. It could follow those links. We're also universally defining many of our terms. So we've got many code lists in GA that contain valuable information about things. Sometimes they're classifying types of rocks and so on. Sometimes they're mundane. You know, they're just lists of divisions or something like that that you need to know, but they're not going to set the world on fire. But we've created vocabularies of this information that are machine readable. They're standardized, and they allow anybody to precisely understand our definitions for things and how those definitions relate to other definitions. So this is kind of, you have to do this to do Web 3.0 stuff. To know what an actor is, to know what a movie is, you have to define that somewhere, and we're doing that. We're doing that for the things that matter to us. Of course, if we were to publish stuff about actors and comedians and movies, we would hopefully just use those previous examples I showed, if they were suitable. So we're implementing well-known Web 3.0 models. So if you're going to work with people who already have a database, you need to know what their database model is. And the various web consortia out there have implemented generic schemas for generic bits. So if you want to describe people and how they relate to organizations, you should do it in this standardized way. Recently over at CSIRO, they've described different elements of time. If you want to talk about time according to Gregorian calendars or microseconds or the Aztec calendar, all different kinds of time. And if you want to convert them, you need a standardized way of doing that. So they've provided this time schema. So we've adopted some of those already in GA. We've adopted one to do with provenance. So that's the lineage or the history of data, and the history of other things too, but in our case, data. Down in the bottom left, we've started to implement systems that can actually store this kind of information and deliver it out on the web. We've got some organisational plans that I helped write when I was at CSIRO in the Provenance case, to think about taking an organisational approach to doing this. So we can say, let's adopt this well-known schema and think about how we can map different things in GA up to that schema so that firstly they're consistent internally, but then secondly that the world can understand how data from one system that goes to another one, how it all relates. And there's a few other ones as well. There's very well-known data models for describing data sets and those sorts of things. So schema.org, that's one of these Web 3.0 description systems. That's the one that I've mentioned before. Google mostly sponsors that thing. Microsoft and others use it. And their recommendation is that if you want Google to better understand your web pages, whatever they're about, use this kind of markup in your web page information. They're obviously mostly concerned about selling vacuum cleaners and whatever else people buy through Google and sites that they find via Google. But schema.org is expanding to include things that are of direct relevance to us, like data sets and countries and all kinds of things like that. And we hope soon in GA to be delivering that kind of information through our normal web page in certain places and through other bits and pieces as well. So we're also building cross-institutional catalogues, and some of those people who are responsible for this are in the room. And we need systems that can operate across agencies, obviously, to do this. So we're using Web 3.0 techniques, actually. We use the catalogues and so on that many of us are familiar with. But ultimately, to relate things in our systems to other people's systems and so on, we need a shared database schema that we all understand. And the database schema we're coming up with ultimately will be one of these Web 3.0 models. In the magical future, we can hope that people who deliver information that's relevant to this, this project, whether they're in our agency or somewhere else, will use those same techniques, and we won't have to centralise stuff in GA. You'll just be able to find it on the web and do the linking yourself. So down at the kind of file level, you know, where does this all go regarding spatial files and things? Some of us in GA are working on taking the techniques for describing things, like, for instance, actor, and you then have a description of what an actor is or person, and you have that published somewhere else and you refer to that. We're taking that and we're putting that into geospatial files. So currently, if you make a netcdf file, which is a container file, it can store arrays of geospatial data. The metadata about that file is essentially textual metadata that's stored inside that file. So it'll tell you the spatial extents, it'll tell you all kinds of stuff about that data. And what we're doing is we're replacing that textual data, so maybe it says this is about radiometrics or some other keyword. We're replacing that keyword with links, hyperlinks, to linked data and Web 3.0 descriptive data sources elsewhere. So right down at the file level, we're seeing Web 3.0 sneaking in. And of course, you could then look at those files and apply Web 3.0 techniques to them to work out, you know, what they're about, how they relate to other files that other people have marked up with this information as well. Better metadata. Okay, so Australian Web 3.0 initiatives. Just a couple of minutes on these. There is actually a a reasonably long-standing now, about 5 years, maybe more, coordinating group for this kind of Web 3.0 stuff. It's the Australian Government Linked Data Working Group. It's very small, it's got no mandate, it's got no funding, but I'm on it. And I'm on it because I think that this is important for the future of the way government deals with internet technologies. What we don't want a particular way of doing things to get locked in without discussion and agreement. We want to describe, which models we use, where we publish stuff, how we publish stuff, who's the authority for certain kinds of data, and the Linked Data Working Group is involved with that. So it's a community of practice. It also provides some of the infrastructure that we need to do things. So for GA, for instance, to publish information about GA in a linked data sense, it needs to have a particular kind of web address to do that. That Linked Data Working Group will supply those, or can supply those, to people who are from agencies that don't have that infrastructure. Another initiative to watch out for is so-called OSNOME. So from the CSIRO publicity piece, it says, imagine that all of the data and information about Australia was linked and readily accessible, and it goes on to talk more about that. What they're describing is, wouldn't it be great if we could actually crosswalk all of the information that we're publishing? And one of the ways to do that, probably the only way, is to think about these kinds of Web 3.0 and schema-style approaches to doing things. So you can see the OSNOME webpage for more information there. There are organisations in Australia that coordinate information stuff generally. So the Australian National Data Service, ANS, they have a series of groups that are related to this kind of stuff. So they deal with publishing vocabularies, they supply tools for that. Provenance, that I've mentioned a couple of times, they assist people with understanding and dealing with provenance. And they've got a list of groups which I guess you could call them either proto-Web 3.0 or some element of Web 3.0. So they're one to watch there as well. In addition to those kind of governmenty things, there are, or cross-government things, there are agency-specific projects, of course. So over at the Bureau of Meteorology, the National Environmental Information Infrastructure is just dealing with how we describe data sets and concepts and so on in standardised ways to work across projects. That's a linked data project there. And there's others at the Bureau of Statistics. National Archives have described some of their information models for classification and so on in Web 3.0 ways, and Institutes of Marine Science and others are also doing this. This is not just GA or CSIRO. Of course, universities, there's new projects all the time at universities, it's hard to keep track. This kind of stuff that we're talking about is just gold for computer scientists. They love fiddling around with piles of data and using techniques to work things out. So it's hard to keep on top of all individual projects, but just one example, I currently have 3 students who started about a week ago looking at implementing a crawler, so that's a web crawler like Google, but specifically for certain kinds of linked data from Australia only. So they're implementing that to go along and find all that linked data and do something with it, maybe bring it down into one very fast database, something like that. The ANU is particularly well known in terms of universities, even internationally, for dealing with Web 3.0 stuff and particularly spatial stuff. And that spatial working group that I mentioned, many of the participants are from ANU. So there's some events in Australia about linked data. There's a symposium coming up that's talking about linking environmental data and samples. That's partially hosted by GA, mostly by CSIRO. And that's dealing with, as I showed before, that catalogue of samples that we've got, getting that information out in ways that other people can understand, so they can find it and they can use it and refer to samples. There's various things like the World Wide Web Conference, which is one of the big international World Wide Web conferences. That's in April. That's in Perth. And I'm going to present on some of this stuff there. Okay, very quickly, related international work. That picture is a conceptual diagram, I guess, of chunks of linked data that have been published on the web and how they relate to each other. And you can see in the middle there where the dark sort of lines are, that's DBpedia. That's a Web 3.0 version of Wikipedia. So someone's sat down and they've written scripts, coded scripts to read Wikipedia and interpret that in light of various Web 3.0 data models, and it's not surprising then that that's the middle of things, because let's face it, Wikipedia is the centre of all our lives. It is for me anyway. Not Facebook. So hopefully the next time they issue one of these, GA will be one of those little circles. So spatial data on the web working group, I've mentioned that, and as I should have mentioned, or I have mentioned, it's a joint working group between the spatial community, the OGC, and the Internet Standards community. So Amy is heavily involved. Aaron, who I've already alluded to, and perhaps others have contributed some of the things that we experience, some of the tasks that we want performed to that working group to consider. So how do I find spatial data, how do I deal with it, and so on. Some of those use cases are considered by that working group. The Research Data Alliance, that's an international consortium of data deliverers, owners, users, government agencies and universities and so on. It's a bit like an international version of that Australian National Data Service. They've got many initiatives that are related to this kind of space. What they're mostly interested in is finding free and open international standards that allow different agencies around the world to either publish or retrieve information and make best use of it. They don't want to be locked into a particular way of doing things, or, well, that's not quite true. They don't want to be locked into a proprietary way of doing things. They want to use standards and data models that are agreed on by communities. And I'm personally quite involved in the Provenance group, but there are many other groups there as well. Companies. So this isn't just a government thing with no commercial side to it. Oracle, that's a big company, obviously deal with databases. They have some products that are in this space. They've got a product called Spatial and Graph, which is interesting. It's both their spatial geoprocessing product and also their machine-readable internet product in the same envelope. And when I first saw that, I just thought, that's crazy. They seem unrelated. But under the hood, the way Oracle do things, it obviously makes sense for them to lump those two products together. They update this product, and they keep issuing it. They keep trying to sell it to us. So they're a big company doing things here. Google and others, I've mentioned, already do things too. And because this space is relatively new, linked data web and Web 3.0, there are small startup companies that come out with new techniques and new tools. And so there's one I like to mention mostly because of the name, Stardog. It's a crazy name. That's their logo. So they deliver a certain kind of web database, a very efficient one, and one that does spatial reasoning actually. So it's of interest to us. And it's a company of like maybe 5 or 6 people who happen to know a certain set of techniques. So there's a whole range of things going on in industry relating to this space. Okay, so that's really the end of the content. I'm just going to quickly summarise, and we'll go over the aims again. So the first aim was to describe what GA does and why, and you heard that from Andy and also from me. I've explained a little bit about what Web 3.0 is. It might be still a mystery to you. If it is, just Google it. That'll bring it up for you. It's mostly a buzzword so that journalists can write about magical new internets. But just think of it as it's the internet that precisely defines things like a database would, and uses the internet to allow you to get around and use that giant database in the sky. I've talked a little bit about linked data and spatial data, some gotchas, don't do this, do that sort of thing. Obviously it's an enormous topic. I go into quite some depth about that in those talks that I delivered last year, which are on the GA website at some point, or I will find links to them. And we're right in the space in GA, so of course we deal with this every day. I've updated you on where GA is up to with Web 3.0 things, and there's a series of projects going on. I've also talked about some Australian initiatives. Of course, GA is involved in those initiatives heavily, and some international work. Where do I think we're going to go from here? We're going to keep doing this stuff. It's becoming more routine. So I think shortly, and I'm obviously speaking off the cuff now, we're probably not going to be talking about what GA is doing in Web 3.0 in the future. It'll just be what's GA doing with regards to data. It'll just become our normal way of operating. In the same way that we don't really talk about we use computers for work. Of course we do. We don't have too many people who don't. So So that's the final sort of thought that I'll leave you with. Is I think that this concept and this stuff we're doing will just become, yes, of course we deliver information on the web according to international groups and models and so on, and building that giant database in the sky, and that international work, the Australian initiatives will all, they will lose their focus on a specific product, this Web 3.0 thing. That's it. Now we're 10 minutes out from the time. Andy might say something, but otherwise, two things. I can take questions, but more usefully perhaps, I'm going to go over to the cafe over there, and if people have specific questions for me or you want to talk to each other about linked data, of course you do, and Web 3.0, the cafe is probably the best place to do that.
Thanks very much indeed, Nick.